How do you use C++ debuggers for reverse engineering? Imagine trying to understand a complex machine without a manual. That's what reverse engineering C++ binaries feels like. Using C++ debuggers like GDB or LLDB can help you see inside the machine and figure out how it works. These tools let you analyze a compiled program without the source code. You can watch the program run, check memory, registers, and call stacks, and see how C++ features like classes and inheritance are turned into machine instructions. Start by loading the binary into the debugger. Once loaded, set breakpoints at key points like function entries or suspected virtual function calls. Since C++ uses virtual tables to handle polymorphism, you can inspect memory addresses where these tables are stored. By examining the virtual tables, you can identify which functions are called dynamically and find their real addresses in the binary. This helps you understand class hierarchies and object-oriented behavior. RTTI, or runtime type information, is another helpful feature. It allows the debugger to tell you the type of objects during execution. You can see class names and inheritance relationships by inspecting RTTI structures in memory. Watching constructor and destructor calls can also reveal how classes are related and how objects are created and destroyed. This is especially useful for understanding complex inheritance chains. When stepping through code, pay close attention to indirect function calls. These often point to virtual functions. The debugger can resolve these pointers stored in virtual tables and show you the actual function being called. This dynamic analysis is vital because static disassembly alone might not reveal the real targets of virtual calls. You can also examine exception handling, such as try and catch blocks, which show how the program manages errors and control flow. By setting breakpoints or watchpoints, you can monitor specific variables or memory locations to see how data changes during execution. This is useful for tracking down bugs or suspicious activity, especially in malware or legacy code. Using the debugger to identify class structures involves locating vtables and RTTI data. Tracing program flow through virtual and non-virtual functions helps you understand how the program operates. Monitoring object creation and destruction reveals inheritance and object lifecycle. Inspecting memory and registers helps you see data structures and variable states. Reconstructing missing source code logic becomes easier when you connect runtime behavior with disassembled instructions. Mastering these techniques makes you more effective at fixing bugs, understanding complex software, and analyzing binaries for security or maintenance. Combining static analysis with dynamic runtime inspection gives you a clear picture of how C++ constructs are realized at the machine level. This approach turns a confusing binary into a story you can interpret and understand.